segment AC. Jack.
AC and BC. Wait, AB and BC are
congruent. Perfect. If BE bisects segment AC, then we can conclude that AB and BC are congruent. All right, so they're asking us, can we conclude that AB and BC are congruent? Absolutely, that's what we just said. Can we also conclude that BE bisects segment DF? How many people think yes, we can conclude that? How many people think no? Guys, you have to vote. How many people say yes, it can bisect DF? How many people say no, it does not? Good, no. Can we conclude that BE is perpendicular to DF? Well, perpendicular lines, don't they make right angles? Did it say anything about perpendicular right angles? So no, this is another no. Can we conclude that B is the midpoint or the middle point of AC? What do you guys think? Yes or no? So they're saying point B right here is the middle point of AC. Isn't it congruent on either side of B? So is it the midpoint? Yeah, it is. Yes. Can we conclude that angle 1 is a supplement to angle 2? Yes. All right. So we are getting into our proofs. And the way we write proofs in this school is we use a 2-column statement reason proof. And every statement will have its own corresponding reason. Now, every reason is either going to be a definition, a theorem, or a postulate, and it's going to be very generalized. We never address the diagram in our reason, and you'll see what I mean when we go on. Your very last statement is always what you want to prove. So if your last statement is not what's being asked to prove, that means you did something wrong. Your last statement is always what you want to prove. All right, definition. A theorem make this pen a little thinner. A theorem is a mathematical statement that can be proved. And we're going to learn 2 theorems. The first theorem is going to be if 2 angles are right angles, then they are congruent. And the next theorem, if 2 angles are straight angles, then they are congruent. All right, so these are theorems, and theorems are mathematical statements that can be proved. We're just going to verbally talk about the proof of these theorems. Well, if 2 angles are right angles, let's stop there. By definition, what's the definition of a right angle? A right angle is an angle that has a measure of 90 degrees. So 2 angles both have a measure of 90 degrees. Don't they have to be congruent since they have the same measure? All right, so we just proved that one. The next one's saying if 2 angles are straight angles, then they are congruent. So by definition, a straight angle is an angle that has a measure of what? 180. If I have 2 angles that both have that same 180-degree measurement, don't they have to be congruent because they're the same? All right, so we just verbally proved these 2 theorems. All right, let's see how we would do a proof with this now. You ready? So it's really not going to be any different than what I've been preparing you for. What have I been stressing since very first day in this class we started doing problems? Go through the given information and do what? Mark up your diagram. Exactly. So when it says that AB is perpendicular to BC, what can we conclude there? If AB is perpendicular to BC, it makes a right angle. Where will it make the right angle? Sebastian, where will it make the right angle if AB is perpendicular to BC? At B, exactly. That's exactly what I wanted to hear. That means we have to have a right angle at B. All right, so now we're going to look. Oh, sorry, guys. Your first statement, so I told you your last statement is always what you want to prove, right? Your first statement is always the given. Whatever is given to you, we list it out. So see how I wrote statement one, AB is perpendicular to BC, DC is perpendicular to BC, and I wrote reason is the given. That's what it always is. First statement is always what's given to us, and our reason is given. And our last statement is always what we want to prove, and the reasons will always vary. So let's keep going. So now we have our givens written out. We're going through, we're marking the diagram. And we made a right angle by angle B. Anywhere in our proof, did it specifically state that angle B is a right angle? No, so we have to write that down in the proof. This is where statement 2 is coming in. So I'm going to say angle B. And then it says and. Well, that means there's going to be another right angle, I guess, right? Let's keep going through the given. Where it says DC is perpendicular to BC, what can we conclude there? Stella? Good. We can conclude that angle C is a right angle. So I'm going to say angle B and angle C are right angles. And if the two statements have the same reason, just like we did in number 2, we're allowed to put them in the same statement. So if two statements have the same reason, we're allowed to put it in the same statement. So just like we said, angle B is a right angle and angle C is a right angle, we put them together because it's for the same reason. Okay, so now we have to tell the reason. We have to tell the reader, how did we know this? How did we know angle B and angle C were right angles? You tell me, what part of the given told us that they were right angles? That it says they're perpendicular. So what we're going to say is def of perpendicular, and these are segments. So def of perpendicular segments. So our reason is always telling the reader what led me to make this conclusion. What was it that led me to make this conclusion? Well, it was I know the definition of perpendicular, and that made me say that they were right angles. All right, so now we have angle B is congruent to angle C. Well, didn't we just state that they were both right angles? And didn't we just learn a theorem that right angles are congruent? So that's what we can write. We can say right angles are congruent. And that's a theorem that we just learned. Okay, next one. So our given is diagram as shown. We want to prove that angle, EFG is congruent to angle HFJ. Well, what kinds of angles are EFG and HFJ? Jack? Straight. Did we just learn a theorem that said if two angles are straight angles, then they are congruent, right? Okay, but now we have to write a proof on this. So what's the first thing we always write in our proof? First thing we always write is our what? Stella? The given. So I'm going to write statement 1, which is our given. It says diagram as shown. And the reason is given. Now, Jack told us we know that these two angles are congruent because they're both straight angles. And he's right. But anywhere in our proof, did it state that they were straight angles? No. So we have to write that down. So we're going to say angle EFG and angle HFJ are straight angles. And how did Jack know they were straight angles? Because nowhere in the proof did it tell us they were straight angles. So how did Jack know? Jack know. Only Stella knows, nobody else. Okay, Stella. Good. Isn't straight angle something we're allowed to assume by looking at the diagram? One of the only things we're allowed to assume. So what we can write is assumed. Since it's really the only thing we're allowed to assume, we're going to say assumed. And now what's the last thing we always have to write in our proof? The last statement is always what? So the first statement's always you're given. The last statement is always what? Jonah. The proof, what we want to prove. So I'm going to state angle EFG is congruent to angle HFJ. Now, Jack told us they're congruent because they're straight angles. You cannot write because they are straight angles. You cannot write that. What do we have to use? It's either a definition, a theorem, or a postulate. Is there a theorem about straight angles? Yeah, what does that theorem say? Good. So I'm just going to say straight angles are congruent. Luciana, could you take off your watch and put it away, please? Thank you. Okay, next one. So this was nice. What have I already done? I wrote out the given for us, right? In that first step. But do we still need to mark it in our diagram? Yeah. So it says angle MBA. So this whole angle, MBA, is 84 degrees. And then it says angle ABO is 42 degrees.
But didn't it say or like for like
No, so here it says angle MBA equals 84, and then it says angle ABO is 42.
so like it could not be given there and that could just be
This says prove, so this is what they want us to prove. And just to save a step, they just wrote the given just one time in the proof. Okay, and then statement 2 says angle MBO equals. Well, did it say anywhere what MBO equals? No, but can we figure out what MBO equals, angle MBO equals? Yeah. Good. MBO equals 42. How did you get that? No. Subtraction. So we're just going to write one word, subtraction. Didn't we take 84 and subtract 42 from it? That's how we got it. So I'm going to label my diagram that MBO is 42. Okay, now it says angle MBO is congruent to angle ABO. This is what we want to prove. It's the last thing written. Well, in my proof, I've shown that MBO is 42 and it was given to us that ABO is 42. Aren't they the same? Since they're the same, don't they have to be congruent? Isn't that the definition of congruent? Two angles that have the same measure? So we can say def of congruent angles. Def of congruent angles, because the definition of congruent angles is two angles that have the same measure. Wow, it's a long lesson. All right, let's keep going. So what I want you to do right now, and I'm going to come around to look, I want everybody to mark their given information. So the given information wasn't written on the left, but is there still given information? Yeah, how do I know it was the given information? Because it's always what? The first step in the proof. The first step of the proof is always our given information. So I want you to go ahead and mark the given information in your diagrams, and I'll come around and look. Perfect. That's not what it says. It's that. It says erase the marking side. It says angle RST is 50. So go to angle RST, where's angle RST? And write 50 inside. Yeah. And then it says angle TSV is 50. So never mind that. Yeah. And then it says angle X is a right angle. So yeah. Perfect. We want to mark it exactly as it says. So I don't want the 90, I want you to actually mark the right angle, don't write 50. Okay, so here we have, yes. Oh, I didn't see yours. Good. So we have angle RST is 50, angle TSV is 40, and then it says angle X is a right angle. I don't want you to write 90, I want you to mark the right angle. I don't want you to write 90, I want you to mark the right angle. Okay. Then it says in step number 2, it's telling us RSV right here. So they're saying this whole angle is 90. It didn't say that it was 90 anywhere in the proof. So how do you think we're justifying? How did we get 90 for angle RSV is 90? Good, we added. You don't have to say you're never specifically addressing the diagram. So all you have to write is addition. We added. So this was addition. Okay, so now the reader of the proof really doesn't understand. Right now, we want to prove that RSV, which we just said was 90 degrees, is equal to angle X, which is said that it's a right angle. So here we have RSV. Actually, let me change my highlighting color. We have RSV is 90, and here it says angle X is a right angle. Do we know that angle RSV and angle X are congruent? Because we know that a right angle and 90 degrees means the same thing. The reader doesn't know that. The reader sees that they're both written in different formats. The reader sees, well, angle X is right and angle RSV is 90. That doesn't look the same to me. The reader doesn't understand. So we have to tell the reader. So now that's why we go to this next step and we say, okay, well, angle RSV is 90 degrees. So we're telling the reader that angle RSV is a right angle. And how do we know that a right angle is 90 degrees?
Could you say like depth of?
Excellent, because isn't the definition of a right angle an angle that has a measurement of 90 degrees? So we're going to say def of right angle. Def of right angle. All right, and the last statement is always what? The last statement is always what we want to what? Not Stella, somebody else. Not Caitlin, somebody else. Jack in the back. Prove. The last statement is always what we want to prove. And what we want to prove is angle RSV is congruent to angle X. Now, I am not able to say definition of congruent angle. I'm not able to say that because the definition of congruent angle is two angles that have the same measure. But in my proof, I only wrote one measurement. So I didn't say 2 measurements. I only wrote 1 measurement. But I did declare them both as right angles. Wasn't there a theorem about right angles? What did that theorem say? Right angles are congruent. So that's what we're going to write as our reason here. Right angles are congruent. Okay, I want you guys to try independent number 5 and number 6 on your own. And I think we'll stop there and then just finish up this packet tomorrow. What do you guys say?
Yeah.
Sound good? Okay, so do independent 5 and 6 on your own, and then we'll do more of the packet to finish up the packet tomorrow. Once you're done with number 5, raise your hands. I'll come check you. You can't have perpendicular angles, but you could just say depth of perpendicular, or you could say perpendicular segment. Yep, perfect. You can go on to the next one. Perfect. So there's no such thing as perpendicular angles. So you could say perpendicular lines make right angles, or you could just say depth of perpendicular. And then your last step is good. Anybody else ready to get chat? Anybody need my help? So people see something and these are right angle. Oh no, you were good. Depth is? No, depth of. Right. So now which angles are right angles? So this blue D is perpendicular to AB. So isn't that angle A right there? So you can say angle A is down. And now since angle A is a right angle and angle B is a right angle, that would say they're congruent to circle right angles. If there's a theorem. Angle A is a right angle, depth of right angle. No, the definition of right angle is an angle that doesn't 90 degrees. So we can't say that. How did we know angle A was a right angle? Marked it. What from the given made you mark that? Yes, so it's not depth of right angle, it's depth of perpendicular. And then angle A congruent to angle C. And we can say that congruent angles. Congruent angles, so we may have the same measurement, but we didn't talk about any measurement. So there was a theorem of talking about what we did say right angles are. Yeah, and that would be the reason. Perfect.
So it's not the definition of a right angle. The definition of a right angle is an angle that is 90 degrees. So how did we know that that was a right angle? What from the given told you that it was a right angle? Yeah, so it's not depth of right angle, it's depth of perpendicular. Depth of perpendicular, because it's perpendicular in the given, that means you look for it. And then that, you've gone through. So once I check your first one, you can go on to the second one. Anybody still ready to check the first one? Not that's the So depth of perpendicular are two angles that have the same measurement, but we didn't talk about their measurement. So there was, we said that they were both right angles. Was there a theorem that said something about right angles? Yeah, right here, right angles are congruent. So you write reasoning. Perfect, you got it.
So now you can close that.
Yep, now you're done. Perfect. Yes, there's geometry lab today, guys. Perfect. So these aren't right angles, right? They're 80 degrees. So we can't say right angles are congruent. This is good. But they're both 80 degrees, right? So this is going to be depth of congruent angles. Yes. Who's ready for me to check number 2? Perfect. All right, once I check your second one, you can close up. I need to get this clock fixed. Perfect. It's not sure. So did we show that they were both 80 degrees? And so the last thing we always write is what? Our proof. So write that down. Here's a statement, right? We want to prove. It's always what we want to prove. Okay, now our reason. Well, in our proof, we showed that they were both 80 degrees. So what is that definition of congruent angles, right? Definition of congruent angles, two angles with the same measure. So we just say depth of congruent angles. Okay, close up. Perfect. All right, I think I checked everybody, yes? Perfect. All right, we will finish this up tomorrow. What happened? If you have to go to lab, I emailed you personally. If you didn't get an email from me, you don't have to go. Unless you want to, then you're always allowed to. Yeah.
Am I going to last?
Yeah, if I didn't email you, that means you don't have to come. Yeah. Yeah, if you didn't get a message from me, you don't go. If you did get a message from me, you do that.
Can we get our phones?
Yes, you guys can get your phones. I'm done for today. Oops, I'm